Hello, welcome back to Cracking the Cryptic, and we got an email from someone at my alma mater. I was a student at University College London back in the day, but a current maths student there is Bo, who has come up with his first puzzle and sent it to us after we got him into variant Sudoku. That's great news. I like the idea that wandering around the UCL campus are people who watch me on Cracking the Cryptic. That's fabulous news. And this is an interesting puzzle. I will tell you reasons why I think this is quite interesting in a moment. But first of all, don't forget that there are loads of links under the video. They will take you to some very interesting places. That includes Patreon, where the month's puzzle hunt is Blobs' fantastic oil and water, where the oil and water cannot mix and you have to have levels of oil and water within cages. It's really clever. Blobs typically has combined that with 12 different other constraints and made some very interesting puzzles as a result. So that's fantastic. There's other stuff on Patreon as well. There's videos of crosswords, Cryptic, and the American Puzzle Final Tournament. Connections, tournament final was what I meant there. Connections videos, various other bits and bobs as well. So loads going on Patreon all the time. Do join us there. There's of course also our apps which feature line Sudoku and domino Sudoku, and our latest Fog of War Sudoku. So very well worth trying. Some great puzzles to be tried there from some of the greatest setters around. I mean, really quality names and quality puzzles. Very good value, as is SVEN'S SUDOKU PAD. And there's also our merchandise. You could get yourself a mug, like I'm drinking from today, that boasts how you watch Cracking the Cryptic. Now, let's have a look at the rules of Bo's puzzle. It's called Don't Even Touch, and normal Sudoku rules apply. 1 to 9 will go in every row, every column, and every 3x3 box, which is relatively normal. Now, read this carefully. Within boxes, even digits cannot touch orthogonally. So you couldn't have 2 here and 4 here, because they would be touching orthogonally. Within a box, it would be fine to have 2 here and 4 here, because they're not within a box, so they can touch orthogonally. So you need to get that rule clear in your head. Now, adjacent digits on a green line have a difference of at least 5, the standard German whispers rule. So that pair could be 1 and 6 or 1 and 9, but they couldn't be 3 and 7. And digits separated by a black dot have a 1 to 2 ratio. So this could be a 3 and a 6 or a 1 and a 2, for instance. And that's it. I love the fact that this is, given those rules, that this puzzle can be disambiguated just with a set of digits entirely clued, as it were, with the clues almost entirely clued within the Fistermafel ring. And just a couple of little disambiguating black dots. Actually, there's a symmetry around the green lines as well. That's really interesting. I don't know how this is going to solve. I do think that that rule about even digits not touching orthogonally within boxes is going to be important, so bear that in mind when you do it. I'm going to start now, and we're going to see how it goes. Let's get cracking. You may be able to tell from the video length how hard I found it. Okay, I am starting to think about the even digits in boxes rule. But it's not going to stop me telling you the things I know about green lines, which are, firstly, that 5 can never go on them, because there's no Sudoku digit 5 can touch and obey the rule. Secondly, that therefore a line alternates between higher than 5 and lower than 5, higher than 5, lower than 5, etc. And thirdly, that you have to be a little careful where you try and place 4s and 6s on green lines, because if they were in a position like this one where their 2 neighbours could see each other, if you tried to put a 4 there, both of its neighbours would have to be 9, and they'd both be in the same box. That's what I mean by seeing each other, being in the same box, row or column. So that wouldn't work. So, first things first, all of those cells have some green in them in the central box and can't be 5. That only leaves one place where 5 can go. row 5, column 5 is 5. Now, the trouble is, I wanted to then say 4 and 6 are a pair here and here, but I cannot say that because I think these digits are potentially monogamous digits, i.e. you could put a 4 here and 2 9s there, wouldn't see each other. Yes, they'd be on the same line, that's not a problem. So the trouble is, even if I colour, I told you about the alternation along these lines, even if I colour one of them in pink and green, ooh, yes, that is right, to alternate between high and low, and then try and work out which is high. Oh, no, it is good. I was going to say I wouldn't be able to colour this one, but I can, from the simple principle that we can only have 4 of these pinks within a box. These lines are exactly symmetrical, and there must be only one pink on this line, so it's got to be there. These 3 are therefore green, and these are all pink. And I don't know whether pink is high and green is low or the other way around, but I do know that they alternate in this pattern. When I find out which is high and which is low, this will apply. Now, does that mean that it's going to take the black dots to disambiguate between high and low in this puzzle? I suspect it does, although it's not impossible for these lines to... No, I mean, yeah, it is definitely true. I've just remembered, in a German whispers puzzle, if you only had German whispers lines, you could never work out the difference between high and low. There would always be at least 2 solutions. To just try and explain that further, if you only had green lines given to you in a puzzle, whatever the official correct solution is, you could subtract each digit in it from 10 and it would still obey the rules. So, I don't know where that leaves me. I don't really know what I'm doing yet. These digits can't be monogamous. I mean, I could try and solve this with placeholders. Oh no, I'd forgotten the rule. I've been doing high and low. Okay. Within boxes, even digits cannot touch orthogonally. Right. It is very, very important then to think about the issue of how we're going to populate the boxes with it. Oh, okay. I'm now beginning to wish I had not coloured for high and low. I tell you what I'm going to do, because I think this puzzle is going to be more about odd and even, and I'm always... This is a rod we've made for our own backs on the channel. We generally colour odd and even puzzles with blue for even and orange for odd. But we generally colour high and low puzzles with high for orange and low for blue. Now you can't do both. Blue can only mean either even in a puzzle or low. So maybe I will stick with green and pink for high and low and just try and work out what they are. And then also colour for even and odd. Now, in this box, we obviously know that 5 is an odd digit, which I'm going to make orange. That is allowed to touch even and odd digits. There's no problem. But even digits are not allowed to touch each other. So in this group of 8 cells, they're going to be kind of pursuing each other a bit like a conga or ring a roses with alternating. So if that's even, that'll be odd, that'll be even, that'll be odd, that'll be even, that'll be odd, that'll be even, that'll be odd. But the other way around, if that's odd, then all the corners will be one colour. So I'm going to need another colour now. Let's go, no, let's not go violet. Let's go red and yellow. So I don't know whether red is odd or yellow, but I do know that these alternate like this. And this digit, I don't know what this means at all yet. Sorry, I haven't even figured this one out. Now I'm in a just state of massive uncertainty. I'm in a Heisenberg level of uncertainty. I don't know whether purple is high or low and green the other. And I don't know whether it's yellow or red or odd or even. Okay, something. Do I solve this with placeholder digits? I don't know. I don't even know whether to placeholder for odd and even or for high and low. This is very confusing to me. Right, I need to come up with a rationale and try and solve the puzzle somehow. So, if this was a 6, 6 is in one of these cells because the other ones in the box are either a 5 or non-monogamous. So if that's a 6, this is a 1. If that's a 6, this is a 1. So, yeah, okay, that's really good. Right. This is a 1-9 pair. What I just said was, I didn't quite expand it enough. If this is a 6, that's a 1. If this is a 6, both of those are 1s. But that would always be a 1. If purple is high, one of those two will be a 6, and that will be a 1. Conversely, if purple is low, one of those will be a 4 and that will be a 9. And the same works on the other end of this line. Those two are the location for either the 6 or the 4 in green. So this is a 1-9 pair. This middle box is beginning to remind me of magic squares. Now, that's great. We now know that these are odd, and we know that yellow is odd, and I'm going to make yellow orange. And I'm going to make red blue, and that at least reduces our palette to 4 colours. And blue is going to be even, not low, even. And orange is going to be odd, not high. So this is a 3-7 pair. It's beginning to look exactly like a magic square. Have we got a magical, hidden magic square, I wonder? Anyway, never mind about that. What can 3 and 7 touch? Not another 3 or 7, and I mean the row geometry will tell you that. These must be, if that's a 3, this is 8 or 9. If that's a 7, this is 1 or 2. Same is true over here. Okay, these did, yeah, so now we know, because we found out they're odd because of the alternation, they can't be 4 and 6. So now 4 and 6 are in these corners. These corners are 2 and 8. They're in a right old 2 and 8. Cockney rhyming slang for estate. That doesn't really advance my knowledge of how the puzzle works, but these digits now cannot be 4s or 6s. Because they're touching a 2 or an 8, and only 1 or 9 can touch 4 or 6. So these are from 1, 2, 3, 7, 8, 9. Now, are we working our way towards this black dot? Probably not, I hear you say. Although, it's quite interesting to speculate where 4 and 6 go in the middle row. Oh no, hang on, these see a 1-9 pair. That's not uninteresting as well. Do we know about high and low? No. No, not outside the central box we don't. Not yet. Something that is worth noting is if you find that this cell is high, sorry, I used the wrong letter. I used the wrong adjective, and I've used it twice. If you found out that this cell is even, that's what I'm trying to talk about, it would be very interesting, because within this box, remember, evens aren't allowed to touch orthogonally. So if that was even, these would all be odd, and the only place you could fit 3 more evens would be there. So once position 2, 4, 6 or 8 in a box becomes even, all of those positions become even immediately. If that turned out to be even, that would be the pattern in the box. Same there, same here. So that didn't apply in the center, where these turned out not to be even, but it could apply in any box. What am I meant to be able to deduce from the 2 8s? I feel like there's something. They are touching, well, they could be touching a 3 or a 7. Just because a square in the corner of a box is odd doesn't necessarily mean that you get this even pattern, because you could get this even pattern if this was odd. So I just point that out for posterity to understand. Right. Well, okay, where do 4 and 6 go in the middle row? It's a question I nearly asked. Maybe I did ask it about 3 minutes ago. I didn't really think about it enough. I'm thinking about it now. It's not so much can these be 4 and 6, which was the bit I was looking at before. It's where do 4 and 6 go at all? And the key point is they don't go next to each other, because even is not allowed to touch even orthogonally within a box. Therefore, in these 2 dominoes I've got highlighted, there is a 4 in one of them and a 6 in the other, and in each case the other digit in the domino is odd. And therefore in these 2 dominoes we have 2 odds and 2 evens, and that means these 2 digits have to both be even, and therefore they're a 2-8 pair. And therefore these other digits, even though there's no German whisper lines between them, are made up of 1, 4, 6 and 9. Oh, maybe there is, I don't know what that means for this line either, because if that's 1 or 9, this could be anything. But if that's 4 or 6, this has to be 1 or 9. But we got that these are even, and that's it. That's what I said earlier. If we found that these were even in a box, then we can draw in the pattern. I first learned this in a puzzle about tables in a restaurant during COVID. It was very, I don't know, it's funny how circumstances bring memories back to you. Anyway, now we know the exact patterns in these boxes because of the reasons I described earlier. And we know that this is an odd digit. So that is 1 or 9. That is very disappointing. It would have been much more helpful for that to be 4 or 6. Same here, exactly. So, now remember that the effect of these blue and orange do not ramify outside the box. So that being blue says nothing about this cell. However, this being orange on the black dot says that that is orange and this is even, because the black dot needs an even digit. The only orange digits the only odd digits that can go on a black dot are 1 or 3. You multiply them by 2 to get the even counterpart. That's 2 or 6. And these cells are now odd because they're touching an even cell. Now, the remaining 3 evens, this can't be even, because those would all be odd and you couldn't fit 2 more even cells in. The same is true of that. So those 2 are definitely odd. I don't know where the 3 evens go, but I do know that those ones are odd. Now, if that was a 1, both of these digits would be 9. They would both be high. I don't know if that specifically means anything to me at this point. I also don't know if this is even. I do. Actually, I do. And it's not. I think this is right. This is green. Green is high or low. And this is green. So let's imagine that green is low and this is therefore a 2. This is also green, but it can't also be a 2. So to be low, it would have to be odd. So that is definitely odd. And that means we know where the 3 evens in box 1 go. This is such an unexpected puzzle. Right, here is the column to focus on. We've got 2 evens so far. We're going to have 2 more. And they're both going to be in box 7 and they mustn't touch. So they go there. The cells touching them are all odd. We can count in column 2. We've got 3 evens. We need another one. The cell next to that must be odd. And then I don't know which of these last 2 is even. But I've found a lot of even digits in columns 1, 2, 3 now. I mean, I've found a lot of even cells. I don't know what the digits are. That would be asking too much. How am I ever going to get digits out of this puzzle? It feels so difficult, but that was interesting about those both being green, so that couldn't be even. Yeah, we can do the same here, obviously. These are both pink, so this can't be even in exactly the same way. So this is odd as well. And what does that have the same effect as here? No, because I had that even digit. Okay, this is odd. What do I know about this box? I know that there are 4 even digits to go into it. What I could do now is divide the rest of this box up into dominoes. And I could actually choose how I arrange those dominoes, and it doesn't make any difference. Each of those dominoes must have 1 even and 1 odd digit, because however you divide up the box, there will be 4 dominoes. And even can never sit next to odd. So they can't either both be double odd, or you'd be creating a double even domino somewhere else, or double even because it's not allowed. So any pair that can form a domino like that pair must have 1 odd and 1 even in it. Now that's interesting for this one because it's got the black dot. So that's 1 odd and 1 even. It's either a 1, 2 or a 3, 6 pair. I think I said at the beginning in the rule explanation I used 1, 2 and 3, 6 as my examples. I did not know then I was going to find there was an odd digit on this black dot. I'm quite pleased with that deduction. Yeah, look at this column. That's another domino with 1 even and 1 odd in it. And there's only 2 evens achieved in this column so far. So there've got to be 2 evens in box 3 in that column, and they've got to be there and there. And they've got to be surrounded in their box by odd digits. Now, this time I cannot colour this blue because I don't know how many evens we're going to find here. We might find 2 or we might find 1. That's got to be odd, because if it was even, you couldn't get another even in. This row, where are the 4 evens going to go? Perfect. 1 there and the other 2 there. And they're going to be surrounded by odds. This is such an odd puzzle. Those 2 have to be even now. And this digit is even and is 2 or 8 again. Now we can just count the rows. That has to be odd, that has to be even. In this column now, perfect, we've got 2 evens, we need 2 more. They have to be there. This is the odd digit, that's the even one. These are odd because they're touching an even, that's touching an even, so that's the last even. In this row we need 2 more evens. Once we've got them in positions 4 and 6, we know we can put them in 2 and 8. And then everything else in that box is odd, and then we can complete the odd and even colouring with an even there and an odd in the corner. Now, this odd is 1 or 3. This even is 2 or 6. This is not 2 or 8 because it's odd. Now, we still have a big transition to make to actually know anything about which is high and which is low. That has not been achieved at all yet. But this line is going odd, odd, odd. Right, this digit is in the same box, so no, that's not useful. Okay, if that was 1, this would be 9 and this would be 3. That doesn't help, does it? I don't see how that helps. Do I know that those are a different 1 and 3? Do they have to be one of each for some bizarre geometry reason that I can't see? Oh, I do know that's even. I've marked it as such. So in this column we've got a 3-7 pair in the odd cells and a 4-6 pair in the even ones. Does that do anything for me? No. Well, or does it? This is, I just don't know about high and low, especially once I get off the green lines. Oh, I do, of course. These 1 and 3s are low. But I don't know what colour low is, of course. Oh, I'm finding it so hard to try and colour for both parity and polarity. Oh, goodness, I'm sorry. I know I'm not being brilliant here, but there we go. It is what it is. Right. If that was a 1, it's the same polarity as this, and that would be a 2. And that would make this a 3-6 pair. That doesn't resolve what it is. Oh, this green 2-8, where does that go in box 8? It's got to go here. So this is from 4 or 6. And it's not pink, so that's green. And this one is therefore pink in the box. And this now has to be pink, because in this row we must have 2 pink and 2 green. And therefore, no, I don't know what colour this is, because it's always low. If that's 6, it's a different colour from pink, it's green. If that's 2, it's the same colour. Oh, that's weird. But this is pink as well. I mean, I need 2 pinks and 2 greens in each pair of blues. But I don't know what digit this is. It could be any one of 2, 4, 6 or 8. I don't think I know. That's maddening. Okay, so this, though, is a 2-8 in pink in this column. That's what we need. This one, we must know in some way it's a 4-6 in pink. So this one is green. I have a feeling this is going literally nowhere now, this analysis. That one was pink. This is where we actually got the polarity onto a black dot. And it did nothing. It did nothing. Why did it do nothing? Or do I say, where is this digit in box 6, it's in one of those cells. I mean, it could well be there and be a 2, but it could also be there. No, it can't be there, can it? Oh yes, it can. In this row, in the evens, we've had 1 pink and 1 green. So that could be either pink or green. In this row, in the evens, we've had pink twice. So they're both green. And the same opposite in this row, they're both pink. So this is pink and that's green. And here we go. This digit has to be there in box 6 and it's a 2. And I got the first digit in this puzzle in minute 1 or 2. I wrote that 5 in, probably in minute 1. And the second digit is in minute 27. I know that those two are the same and they must be 2s. And this is huge, because now I know that pink is low. I also know that that's a 1 and I can colour it pink therefore. But I know that pink is low, so let's trace along these lines. 8, numbers. 8, 2, that's 1 or 3. This is 7, 1, 6. This is 4, 9, 3, 2. 8. Green is high. I mean, this is just a breakthrough from that and that. Oh, it's so clever, Bo. This is great stuff, by the way. I'm really impressed. That's a 4, that's a 6, because we know their colours. I can write in 2 and 6 by Sudoku now, and 8 and 4 there. 6 in this box is there. Look, I can do all the evens, hopefully in the whole puzzle. And they're just done. It's magic. That's an 8, that's a 2, that's a 6 on my black dot, so that's a 3. 6, 8, must be able to do all the evens. They're just done. They just cascade out of the puzzle like something very nice. I don't know what my metaphor is here. That is not 1 or 3 anymore. That's 7 or 9. Okay, so here we are now. What do we do next? That 1 sees that digit. That makes it a 3. This is not being seen by anything. Okay, 3 there means one of these two is 3, but there's a 3 there. So we put 3 here. Then one of those two is 3. 9, no. One of these two is 1. I did spot this a moment ago. One of these two is 1. And therefore the other digit, well, it's high. It's 7 or 9, but it could be 7 there or 9 there. If that's a 7, that's also a 1. But if that's a 1, this is a 9. I don't know. Not finished yet. We finished the evens, but the odds are going to be a bit trickier, I think. And I don't really know what I'm doing, what I'm about to try and find. I must use this 3, surely, that we found. 3 is in one of those two cells in box 7. And one of those two in box 8. But it's almost more important where it is up here. I don't know. Okay, let's do a bit of Sudoku pencil marking. When in doubt, fall back on the obvious. That's 5, 7. This is so unlikely to yield. I think I've got to think of something clever still. This is not a 5, obviously, because it's green. Now, that's 1, 3, or 9. What is this? 1, 5, or 7? It can't be 5. It's 1 or 7. So if that's 7, that's 1, and then this must be 1. If that's 1, this is 9, and then this must be 9. These two are always the same as each other. I mean, that's interesting. Oh, so that's never a 3, because that would be 1. No, 3 can't connect to 1 or 7, that's why. Right, so I bet that applies here. This one is 3, 7 or 9. So this can never be 7. And it can't be 3 by Sudoku. This can never be 7 because it'll always be too close to that digit. So this is 1 or 9 as well. And it's the same digit as that, and they're the opposite of the digits on the other line. Now, what does that do? I don't know. I've got this odd imbalance that I know what that is, but not what that is. So this might be a significant and helpful digit. And these two are the same. I mean, I look into box 7 using that, and it doesn't really do anything. It keeps it out of those 2 cells, but it's not very interesting. Wow, I'm really missing something. Oh, 3 is there, so this can never be a 3. So this is high. That's what I'm missing. This cell is seeing 1 and 3. That's really very simple, sorry. So that is high. These are both 1s. In the row, that's a 9. This is 1, that's 9. Oh, this is going to do it. That's going to do it. So now I can place 9 in box 9 appropriately. That's 5 or 7. In this column, this is a 1-3 pair, I think, now. In this row, that's 5 or 7. But look, I've got a 7-9 pair in the column. So that's 5, that's 7, that's 5. This is 7 or 9. That's 7-9 pair. Let's use it again. We can place 3 there and 1 there. This is now a 7. In the column, that's a 3. That's 1. This is a 5-7 pair. This does seem to be working. 9 there, that has to be 3. That's a 5. That fixes 7 and 5. I can do 9 here and 5 here and 1 and 7. Going up this column, I've got a 3-5 pair, 7-9 pair not resolved. That 1 is sorting out the 3-1 pair. That looks back at the 3-5 pair. That looks right at the 7-5 pair. This is a 9 in the corner. That's 5. That's 7. This is 9. That's 7. This is 9. And that's 7. And there we go. What a fabulous puzzle. That's really clever, Bo. So interesting that this all gets disambiguated. Beautiful setting. Yay, UCL. Here we go now. Thank you very much for watching us on the channel, as always, and for sending us your wonderful stuff. Thank you for the kind comments as well. They are much appreciated when you are kind about, especially about our slight inadequacies. I will see you again tomorrow, I hope, for more Sudoku fun. Bye for now.